atmosphere, the first most important chapter regarding air pollution. Well, so to know that air pollution, about the air pollution, the structure of the atmosphere, the segment of the atmosphere is very much essential to know. So to begin with, it is divided into certain layers called troposphere, stratosphere, mesosphere, thermosphere, ionosphere. We will go into details one by one. First of all, the first layer, that is there up to 7 km diameter height, altitude, it is called troposphere. Now maximum turbulence, the storm is there in the troposphere. Our aeroplanes are also moving in the troposphere, except jet plane. And there are different layers. It is divided into A1, A2 layers for aeroplane. Then from 7 to 50 kilometer, 7 to 11, this kilometer is called, it is less turbulent actually. So 0 to 7 kilometer is called trochosphere, 0 to 11 kilometer is called troposphere. Now 11 to 50, it is called stratosphere or the ozonosphere. 50 to 85 kilometer is called mesosphere, and beyond that is thermosphere. 85 to 500 kilometer is called thermosphere. The upper layer of the thermosphere, some portion, is called ionosphere. Now let's go into detail one by one. First, in the troposphere, 0 to 11 kilometer, as I told already, there the temperature found to be drastically reduced from 15 degree to minus 56 degree centigrade. That means temperature drops with the altitude, with the height. Why the temperature drops? Because that most of the atmosphere is present near the ground, absorbing the sunlight, the IR radiation, and so nearby the ground the temperature is comparatively higher. As you go at a higher altitude, the atmosphere become more and more rarefied and the absorption of heat gets reduced. So at a higher altitude, temperature automatically gets dropped. Now but in the stratosphere, from 11 to 50 kilometer that height, it is found that temperature is increasing with the altitude. That means at 11 kilometer, that is called troposphere, the temperature is more or less minus 56 degrees centigrade, and it increases to minus 2 degrees centigrade at the stratopause. So stratopause to stratopause, this particular region, the temperature rises from minus 56 degrees centigrade to minus 2 degrees centigrade, and this rise in temperature is due to the absorption of heat by the ozone gas. That's why it is called ozone layer. The ozonosphere or the ozone layer, the ozone is capable of absorbing ultraviolet radiation, and ultraviolet is high energy radiation. It is reacting or interacting with the ozonosphere, thereby rising the temperature. As you go at a higher altitude, more and more irradiation of ultraviolet, and accordingly the temperature also rising. Now in the mesosphere, that means the stratopause to mesopause, that particular region called mesosphere, temperature again changes from minus 2 to minus 92 degrees centigrade. So temperature drastically drops in the mesosphere, which is called the coldest region. It is the coldest region. Temperature is minus 2 to minus 92, and that drop is due to the absence of atmosphere. Simply we can say it is due to the absence of atmosphere. The gas is very much rarefied here, no absorption of IR, neither there is any absorption of UV, and thereby temperature drops drastically in this rarefied air. Now from mesopause to thermosphere, that higher altitude means 50 kilometer to 85 kilometer, that is called thermosphere. The temperature again increases, rises quite high. It goes up to 1200 degrees centigrade, positive 1200 degrees centigrade. That is quite high, and that is because of absorption of energy or radiation from the outer space, cosmic radiation. This cosmic radiation consists of it is a solar flare, or it may be from different type of cataclysmic phenomena that is happening in the outer space, that is neutron star collision, or maybe collision among the galaxies. So that gamma ray burst, this type of high energy radiation coming from very long distance, also maybe much longer distance from the outer solar sphere, so much beyond our solar system. So that's energy is coming out. It is called, in general we call it cosmic radiation. So this, because of this cosmic radiation, which is very high energy radiation, the temperature goes up to 1200 degrees centigrade. Now the question is what is the relationship of this with the air pollution? Well, air pollution is created mostly in the tropospheric region for different phenomena. Industries, the automobiles, using automobile fuel, burning of fossil fuel, different type of gas is going into the atmosphere, and we are getting this pollution problem. Rather, regarding air is colorless, odorless, tasteless. It's a mixture. It contains oxygen, nitrogen, and different type of other gases in a small quantity: carbon dioxide, carbon monoxide, nitrous oxide, nitrogen dioxide, nitric oxide, and so many other gases also in the trace quantities. This composition of air we can classify into three categories. One is called the major composition, that is consisting of nitrogen and oxygen, 21% oxygen and 78 around nitrogen, 78% nitrogen. So that is major category. Now in the minor category, argon, water vapor, and carbon dioxide up to 0.034%. Then you have trace quantity of different inert gases, different type of inert gases: helium, neon, krypton, xenon. This type of gases are also present, very small quantity. Now pressure of atmosphere is 14.7 pound per square inch. That is quite known factor. Now atmosphere is special because it is containing the life sustaining oxygen. Now carbon dioxide is also very much essential for the plant growth, for photosynthesis, and the food is also produced due to by this photosynthesis process. Nitrogen is also essential because it is diluting the atmosphere. Without nitrogen, the life form cannot exist also, because nitrogen is diluting the oxygen quantity. Otherwise, too much of oxygen is also toxic. Now there is a phenomena called hydrosphere. There is a phenomena that is happening in the hydrosphere. The water is getting evaporated, going to the air, and finally falling as a precipitation, as a rainfall. And atmosphere, we are there, it is constantly exchanging energy and matter with the other components of the earth. And atmosphere is essential for life. It is supporting the life. Without atmosphere, life is impossible, at least on earth. Now the composition of the atmosphere I was talking about, we have some gas that is constant, that is nitrogen, oxygen. Some gases are variable depending on emission, like carbon monoxide, carbon dioxide. These are variable gases. So when the pollution level is high, this quantity of this gas increases, otherwise it decreases. Well, so this is major, minor, and trace quantity. The gas list is given here. Major, oxygen, nitrogen. Minor, that argon, carbon dioxide. This is minor, and others are all trace gases, very small quantity of different type of gases, particularly inert gases. And the composition, if you go into detail, is like this: how much percentage it is present, every different gases. Oxygen is around 21%, nitrogen is 78%, but others are there, very small quantity. So this is the total chart, that how many different type of gases are present and up to what quantity. Okay, this continuation of different other gases. So from here we can understand that lot many number of gases are actually present in the atmosphere, though very small quantity. So many large number of gases are present, and the unit of this quantity sometimes parts per million, sometimes parts per billion, sometimes it is ppt, parts per trillion, and so on. Now atmosphere structure is divided into major category: thermal and magnetoelectronic. Thermal structure, that how the temperature changes at different layers or altitude. This is the thermal structure, as I already gave some introduction. So here it is given in detail. So up to 10-11 kilometer, the troposphere temperature drops from 15 degrees centigrade to minus 56 degrees centigrade. Now it is going in the at a higher altitude, the temperature again increases up to minus 2 degrees centigrade in the stratosphere. Now in the thermosphere, the temperature ranges from minus 2 to minus 92, whereas in the thermosphere it goes up to 1200 degrees centigrade. This is thermal structure of the atmosphere. Then different layers as it is given here: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Now in the troposphere, the temperature, not only temperature, the different height. So the temperature changes with the altitude. It is called the lapse rate. So from ground up to the 11 kilometer height, temperature continuously drop. So if the atmosphere is dry, it is called dry adiabatic lapse rate, and the value is more or less 1 degree temperature drop per 100 meter. That means per kilometer 10 degree. Whereas if it is a wet atmosphere, the atmosphere contains lot of moisture, then temperature drop is comparatively less. Instead of 1 degree, it is minus 6.4 per kilometer. That means per 100 meter it is 0.64 degree. Instead of 1 degree, it is 0.64 degree. That is called WLR, wet adiabatic lapse rate. So these two types of lapse rate there: dry adiabatic lapse rate and wet adiabatic lapse rate. Now this stratosphere, regarding stratosphere, the height starts from around 10 to 11 kilometer height. So we have ozone there. Ozone quantity is quite large, so accordingly we are dividing it is into UVB and UVA category. 320 nanometer below the 320 nanometer wavelength is called UVA, and above 320 nanometer is called UVB. So UVB is actually below 320 nanometer, which is very dangerous. Below 320 nanometer UVB part is very dangerous. It is giving much more toxic effects, and particularly it is giving skin cancer. So above 320 nanometer, it is UVA is not that much harmful. It is not bad. Well, so it is mostly irradiated to ground, but UVB portion is mostly absorbed in the stratosphere. So that is the importance of the stratosphere. It is absorbing the most dangerous portion of the UV, that is UVB part. Well, above troposphere, stratosphere, maximum aeroplanes are moving in the troposphere. Some of the Z planes are going in the stratosphere. Spy planes, Z plane, they are going in the stratosphere. That is called traffic air level 6. Now the temperature variation with the altitude, the lapse rate. If it is dry, it is 1 degree per 100 meter, and if it is wet, then 0.64 degree per 100 meter approximately. The ultraviolet radiation that is coming from the outer space or from the solar flare, it is mostly absorbed in the troposphere, and only a little percentage of that energy is getting irradiated on the ground. Maximum more than 90% is getting absorbed in the stratosphere. Only maybe less than 10% is coming to the ground. Now we have the mesosphere. Mesosphere, the rarefied atmosphere, it has got very little air. Now the temperature there is very, very low. It is called the coldest layer, ranging from minus 90 to to minus 2 to minus 92 in that range. Okay, so if you go at a higher altitude, temperature drops because air is becoming rarefied in this layer, so neither IR nor UV can get absorbed there. Thermosphere is high temperature region. That is because of cosmic radiation, as I already mentioned, that is coming from X-ray, ultraviolet radiation. It can be, this cosmic radiation is a mixture of so many different type of radiation. It can be gamma ray bursts also. It can be coming from solar flare. Different type of radiation which is very very high energy is irradiated in the thermosphere region. So that's why the temperature goes up to 1200 degrees centigrade. Exosphere is very very rarefied air, almost nothing is present there. So temperature more than 500 kilometer, it is ranges 250 to 500 kilometer mentioned here. It is just in the outer boundary of the atmospheric layer. So it is the transitional zone between the Earth's atmosphere and interplanetary space, means outer space. Now next, that another division, it is called magneto-electronic structure. Okay, magnetosphere, you have the divided into ionosphere, plasmasphere and magnetosphere. So this is not spherical actually. So far we are just drawing, it is spherical, but now it is become donut shape instead of spherical. And ionosphere, it is affected, defined by atmospheric effects on radioactive propagation. It is also divided into D region, E region, F region. Okay, so different altitude. So this is always varying, so these layers are not very fixed, so that height or depth is increasing and decreasing during day and night. So just like D region, it is about 35 to 50 mile or 60 to 90 kilometer, this is disappearing at night. So and E region 90 to 140 kilometer in altitude, these are very very rarefied. And this ionosphere, there are a lot of ions present, H2 plus, H2 H plus, H2 plus, this type of different type of ions present, and some hydrogen helium type of gas along with the ions are there, and there it is attracted by magnet, and because these are all paramagnetic in nature. Now here is the diagram for D layer, E layer and F layer. 60 kilometer, 120 kilometer, 180 kilometer. So if AM radio transmission is happening and getting reflected from these layers, daytime, nighttime also it gets changes. See, there in the daytime there is D layer, E layer, F layer, and the nighttime only there is F layer, because other layers are getting dissolved. Why? Because in the daytime the ions are absorbing the sunlight, more and more ions are formed, and so ionosphere thickness is increasing. But in the night time those ions are getting discharged, slowly they are getting neutralized, and this ionic region is decreased. That's why in the night time only F layer exists and other layers are not present. Plasmasphere, not only it is not spherical but donut shape with a hole aligned with Earth's magnetic axis. That means in the donut shape you will find, and that particularly in the polar region there is a gap. So this plasma sphere, there is a gap you will find near the polar region. So it is like this. So if you just look at here at the slide, yes, so here in the ionosphere, this particular position you will find there is a gap. That means the magnetic field, that plasma sphere is also, this is all magnetic, interacted by magnet, and this plasma, it is cold plasma. So plasma can be hot plasma and cold plasma, like sun is plasma state, but it is called hot plasma because the temperature is very very high, around 6000 degree centigrade Celsius. So but this earth temperature is very very low compared to sun. So here also you get the plasma state, but which is cold plasma. This cold plasma is extended up to 140 150 kilometer high. So this is called plasma sphere. So here also some ions are forming in the daytime and in the night time get dissolved. So this plasma sphere is extended up to a very very long distance, just like this, and the solar flare whenever passing through this plasma getting deflected in both sides, and that's why the earth is getting protected like a cocoon inside, and the maximum solar radiation, solar flare is getting deflected, and so due to this plasma sphere earth is getting protected and the life form can exist. Now the magnetosphere, it is not spherical, it is a cavity in which the earth's magnetic field is contained by a solar wind and interplanetary magnetic field. The magnetosphere, this is the diagram, and we can find mention these two called the Van Allen belt, which is actually situated from the north pole towards the south pole. So it is a glittering because of the different type of ions which are getting absorbing solar energy and reflecting also some of the energy, and that's why these are glittering or twinkling in the daytime, night time, particularly night time it can be seen. So that is called Van Allen belt. So magnetosphere pulse is typically at about 10 earth radii, that means or 35,000 mile or 56,000 kilometer. So it is having a long tail. Okay, so and few million miles long. This tail is quite long, even a few million miles, like this. So this is the earth's magnetosphere, and this is responsible for the that protection from the solar wind.